Okay.
I'm going to say something every time you verbally miss it.
Okay.
Even though I might think that you're thinking it properly, you're just saying it wrong.
Yeah.
I'm just going to point that out every time. Don't take it as a criticism. I'm just
Oh.
telling you how to be more verbally precise.
Okay.
So I have no problem with you saying you solve for y here by dividing both sides by -4/5.
Mhm.
That's fine.
Okay.
That's the same thing as multiplying both sides by -5/4, but
Yeah.
putting that intermediate step in there is no problem. Okay. So that's
Okay.
whatever that number is. I don't
Mhm.
know that I would convert it to a decimal.
Okay. Just leave it as a fraction.
Well, notice the oddity now. You have a decimal number combined with an improper fraction.
Yeah.
We want a single number, first of all.
Uh-huh. Yeah.
So that's not going to ever go, the teacher would take points off here.
Okay.
Why? Because I can combine these. 15
Yeah.
and 2/10 can be combined with 12/5, which is 2 and 4/10. So
Okay.
that should be
Gotcha.
16 and 6/10,
Okay.
even
That makes sense.
16 and 3/5. Uh,
Yeah.
but the point is, you don't want to leave the answer like that. Those are just two numbers. There's no variable there. Whereas
Yeah.
over here on 21,
Mhm.
you've got one of these as a number, the other is a number in front of a variable. So this needs to be kept apart.
Okay.
Okay, but
Yeah.
22 needs to be combined. You merely have two numbers there.
Gotcha. Okay.
23.
Yeah.
Let's do 23.
Mhm.
We have 3/4. Is the x in the denominator or the new or not?
No, it's on the side, like 3/4 x.
Okay, you see the problem with writing it like this?
Yeah.
This makes it look like
Uh-huh.
the x is in the denominator.
Yeah.
And
And
makes
not,
all
yeah,
the
both.
difference in the world, whether it is or is not.
Uh-huh.
Okay? So,
Okay.
let's write it properly. And now, in this one, is y in the denominator?
Um, is what? No, it's, my bad. Yeah.
Well,
No, it's not.
I don't have the stuff in front of me, so I'm asking because I really need to know.
Yeah, no, you're good. It's not in the denominator, no.
Okay.
It's,
And x equals
9
what?
twelfths.
What is x supposed to be equal to?
X is supposed to be equal to 10.
Okay.
Yeah.
All right. So we're going to solve this for y, correct?
Yeah.
When
Uh-huh.
x is equal to 10. So the
O-
very next line, we're just going to substitute 10.
Okay.
Okay, now our goal, isolate that.
Yeah.
So tell me what the next step should be.
Subtract 12 from both sides.
Okay?
So when we do that, uh,
Now let's
we,
represent this over here. Let's call that 30/4
okay.
minus 12
Okay.
for the moment.
Okay. Hmm.
Okay? Now, our next step would normally be what?
Um, divide by -9/11 from both sides, by both sides.
Okay. Problem is that's going to make this fairly complicated if we don't reduce.
Yeah.
Let's reduce it.
Okay.
Let's simplify.
Um,
How do I
okay.
simplify that?
We could do 30 times -12 divided by 4. Which would get,
Hold on.
okay.
some reason all my students have problems with a problem of this nature.
Mm-hmm.
How do I solve that problem right there?
You would put it 4 over 1, and then you would have to find a common denominator.
Okay, let's do it.
Okay. And then the common denominator could be 3.
Okay. So what's this fraction become if it has a denominator of 3?
12 over 3
Good.
minus 1/3. Yeah.
So that's equal
And then
to,
11/3.
okay. So,
Yeah.
do you see why this problem that we're looking at is basically that same problem?
Uh-huh.
It's a fraction being either added or subtracted to a whole number.
Okay.
So,
Yeah.
what are we going to do?
So like what we did on the bottom, we'd put minus 12 over 1, and then we could use 4 as the common denominator.
How many fourths is 12?
3. Or how many?
When you're doing these problems, I want you
Yeah.
to always look at your answer and make sure that you look back at what you started with and you didn't change anything.
Okay.
So what does the bottom have to be? What did you say?
4.
4 fourths. Is that equal to 12?
No.
Okay, so what does the numerator need to be? We know the denominator needs to be 4. That's definitely the lowest common denominator.
Yeah.
What do I need to do there? How do I figure out what that is?
You'd have to, well, so since it's 4, 3 would have to be in the,
Here's what
I'm mixing myself up here.
you divide your common denominator by this denominator.
Okay.
That's equal to 4. 4 divided by 1. And then you multiply that by that numerator.
Oh, so it'd be 48. Yeah, I remember that. Okay.
And 48 fourths is the same as 12. And this is what I mean, is once you've written that answer, always check, make sure that that's the same number.
Okay.
That's where you want to catch a mistake if you have one.
Okay.
You don't want to wait until you get to the end and then figure out where the mistake occurred.
Yeah.
The secret to mathematics is every single row, every time you do a calculation, do the check immediately.
Okay.
Okay? So that's the left side. What does that become?
It becomes negative 18 fourths.
So I have negative 18 fourths. I don't need to reduce it yet. I might have to reduce it at some point. Okay, now what's the next step?
And then we would divide both sides by negative 9 over 11. And then you do same switch flip. So it'd be negative 18 over 4 times 11 over minus 9.
So,
and then
on the right side, we have our y. That's what we want. Now, on the left side, notice that the reason I didn't worry about reducing that is because I figured I'd probably at some point see numbers similar to this.
Yeah.
So, first of all, we're multiplying these two things. How should we multiply them?
Just across.
Well, that's going to result in a big number. If we multiply 11 times 18, you're going to need your calculator.
Yeah, for sure.
You don't need your calculator to do this problem.
No.
What can be divided into that and that?
2.
Minus 9.
Oh, I see what you mean. Yeah, okay.
In other words, when you're looking to simplify fractions, you're looking for the largest thing.
Yeah.
Not 2. Yeah. 2 doesn't even work, actually. 2 doesn't go into minus 9. But
No.
3 does. I could divide both by 3, but I'm looking
you'd have to.
Largest divisor.
Yeah.
The largest thing
Yeah.
is I can divide both of these by 9, and what I'm left with is a 1 there and a positive 2 there. So not only did I simplify it, but I got rid of both negative signs.
Okay. Yeah.
And now that's equal to 22/4.
Mm-hmm.
Well,
Which can be reduced down.
now hold on a second. Let me go back. I didn't even follow my own rules. I can change the 2/4 to 1/2, which is what I want to do immediately.
Yeah, makes it a lot easier.
Before I do the multiplication, because now I'm left with that. And notice the biggest number I needed to deal with was 11.
Mm-hmm. Yeah.
So always simplify.
Okay.
Okay.
Cool.
All right.
Okay. Awesome.
That's good. Here, let me just have a quick peek.
Sure.
We went over that one. And the only reason I'm looking at, okay, good.
All right.
We only have 4 more sessions, and there are some fundamental things here that need to be covered.
Okay.
And I think the next thing we should do are this stuff here. Slope, midpoint formulas, y-intercepts, things like that.
Okay. Sure.
Now, I can pretty much, I think you'll be fine here. What is the slope defined as?
Y equals mx plus b. Or m equals x2.
Hold on.
Minus.
Hold on. What you just gave me was the general equation of a line.
Okay.
And I'm going to write it because that's very important here. What is m?
I'm sorry. What was what?
What is m?
M is the slope, and then
b?
B is the y-intercept.
Okay, and what is slope? How is slope defined verbally?
Rise over run.
That's what I want you to remember forever.
Okay.
Because if you remember this, you can always come up with well, what's the rise?
The rise is the y value.
The y differential. In fact, let's make up a new term here.
Okay.
Which you'll probably run into in math at some point in time in the future. And
probably, yeah.
Change in y. What that delta means, what that triangle means, is the change in y. So it's the change in the y's divided by the change in the x's, right?
Yeah, exactly.
And what that becomes is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1.
Yeah.
So you go straight from m being equal to that is what most people are taught to remember. But I actually think it's better to remember rise over run than it is this, because you should always be able to figure this out from rise over run.
Yeah.
Notice that your xy coordinates, the x is the horizontal one, the y is the vertical one. So the rise has to be a function of y's, and the run has to be a function of x's.
Okay.
Right?
Okay.
And that is the general formula for, in other words, if I told you that y is equal to 2x plus 3, how do you graph that?
You would start at 3, because that's the y value, then go up 2 over 1.
Over which way?
To the right. Yeah.
And connect the dots, that's the graph of that.
Yeah.
Okay.
Cool.
Tell me the following slopes.
Okay.
Just say positive or negative.
Okay. That's negative. That one's positive. That one's positive. That one would be just horizontal.
You read my mind. I was trying to draw a horizontal line and I screwed it up, so I figured I'll just let them answer what it is. What is that slope?
That would just be
horizontal.
Horizontal, yeah.
It's meant to be horizontal, but notice where that is and notice where that is. Given the grid in the background, that's a positive slope.
Is that? Oh, okay, okay.
I meant to draw it horizontally, but it came out positive. No.
It's okay. I was kind of assuming that was supposed to be horizontal.
That's what I said. You read my mind. What is the slope of this horizontal line?
That would be at y equals.
Okay, hold on.
0. Would that be as y equals 0? Or
no, what was the slope? Here's the way you're going to remember. What is the slope of this line right here?
Positive.
What's the number of it?
It's 1. The number? Oh, yeah, y equals.
Slope of 1. In other words, I went up 1 over to the right 1. Up 1 over to the right 1. Okay?
Okay.
Is this slope greater than 1 or less than
1? Greater than 1.
Okay, we'll call that slope 5.
Okay.
What's that slope approximately?
Well, it's less than 1, so.
Is it between 0 and 1?
Yeah.
So we'll call it 1.
So it's 0.5. Yeah.
0.5 is a good guess. In other words, I went up 1 and I went to the right 2, which gave the rise over run was 1 over 2.
Okay.
Okay. Now, what is the slope of this line? Give me a guess.
1/3, 1 over 3.
Okay. What's the slope of a horizontal line?
Just.
What direction are we going? We're going from
horizontal
to a fraction, to a smaller fraction, to what? What's this?
To 0.
Yes.
Yeah, just 0.
That's a slope of 0. So that's how you remember whether horizontal lines have a slope of 0 or whether they have a slope. Let's go the other direction.
Okay.
What's the slope of this line?
That'd be 0, like x equals.
Give me a guess.
No,
first of all, let me say something.
Yeah.
Slopes are not x equal or y equal.
Oh, okay. Just m equals.
What is the slope of the line? Okay. Okay. In other words, how much, if I want to measure this line by rise over run, let's come up with a number. A slope is a scalar quantity. It means it's a number. Okay. Because all I was asking for here was a guess. Okay. In other words, this is 1. This is steeper, that's 5. This is steeper still.
So that would be probably like 10.
Okay.
We could say.
What's a vertical line going to
be? 180. Well, I mean, it's just infinity. Infinitely many.
See why?
Infinitely many.
Do you see why? Not infinitely many. No. The slope is infinite.
Okay.
In other words, if I have a vertical line, the rise is a lot, and the run is 0. So if I have a rise of some number, let's say 2 over 0, when I do that calculation, I get infinity.
Yeah.
They don't like to say that in geometry class, but they prefer calling it undefined. And so that's what they're going to tell you it is it's undefined. A vertical slope, but in reality, it's infinity.
Okay.
In other words, these slopes are getting steeper, right?
Yeah.
Steeper,
exactly.
steeper, steeper. Well, there's no magic number that they're going to stop getting steep. In other words, it's not like this is 1,000. They keep getting steeper and steeper and steeper. This is infinity.
Okay, that makes sense.
Infinite slope.
Okay.
Would you mind holding just a minute?
Yeah, no problem.
Hello? Yes. Oh, yeah. Okay. I am. I am right in the middle of a session, though. Can I call you back in like 30 minutes? Yeah, what was your first name again? Spencer. And I have your phone number. Is this a good number to call you back at, Spencer? Okay. I'll be back to you in 30 minutes. Bye-bye. Wow. Keep getting all these students from Florida. It's amazing.
Oh, wow.
Well,
that's awesome.
I had one woman find my website online, sign me up. I've been working with her son for about a month now, and then she immediately referred me to 3 other people. So
wow.
4 students in Florida that all do everything online, and they're everything from pre-calc to calculus.
Wow. So, well, that's a huge compliment.
Well, it's not such I'm looking for compliments, is that I'm trying to expand my services outside of Colorado, because at the moment, almost everybody that I see is in this King Carl area. So
gotcha. Yeah.
I can expand to places outside of Colorado. It's really going to be helpful, big time.
That's awesome. Yeah.
Yeah. For sure. So that's why I gave the call. I saw the Florida area code, and I thought.
That's awesome. Yeah.
I missed that first call. A lot of times you miss that first call, and by the time you get back to them, they've already found another tutor.
Exactly. Well, that's awesome, though.
All right. Yeah. So now that we know slope, let's do a basic problem.
Okay. Cool.
Give me the slope between these 2 points.
Okay. For -1 would be the slope for that one.
Okay, hold on. Give it to me as a number. Remember, this is a scalar quantity. You can give it to me as a ratio, but don't give it to me as anything -1.
Okay, so it'd be...
In other words, the slope is either 6, the slope is 5/2, the slope is 4/3, the slope is -2. That's what I'm looking for when I say, what is the slope between 2 points? That's when I mean a scalar quantity.
Okay, so the slope of this one would just be 4.
Well,
m equals...
rise over run. M equals rise over run.
Yeah, so it'd be 5 minus 1, which is 4.
You can go that direction, okay.
Okay.
Over what?
Over -3 minus 2. Okay. Oh, my bad.
No, that's okay. You can go that direction. You can go either direction you want as long as you go the same direction with both.
Okay, yeah.
In other words, what you did was y sub 1 minus y sub 2 which is okay as long as you do x sub 1 minus x sub 2.
Yeah.
The reason you did it is because you wanted to do 5 minus 1. You didn't want to do 1 minus 5.
Yeah.
Right? And that happens a lot. There's a lot of times you would rather subtract these numbers from these numbers rather than the other way around. So it's helpful to know that you can go either way, just don't mix it up.
Okay.
In other words,
Yeah, that is.
don't ever do y sub 1 minus y sub 2 divided by x sub 2 minus x sub 1. You'll get the wrong sign on your slope.
Okay, that makes sense.
So what does this equal?
So it'd be 4 over negative 5.
And that is negative 4/5. So the slope is negative 4/5.
Okay.
Now, let's find the equation of this line.
Okay.
Okay? In other words, that is the fundamental of algebra. This you just have to know to go into geometry, algebra 2, anything else. The one question is come up with the equation of a line given either 2 points or slope and 1 point.
Yeah.
So we need to be able to do this. At this point, we have slope and 2 points. So we got more information than we actually need.
Yeah, exactly.
So what's the general equation again?
Y equals mx plus b.
Always start there.
Okay.
Now, how am I going to come up with an equation that looks like this? Y equal 3/4 x. Well, let's see. I know what m is, right? We just calculated m is minus 4/5 plus b.
Yeah.
So I know that much. But I want to replace b with a number. In other words, I want my answer to be y equals some number times x plus or minus some other number.
Yeah, exactly.
How do I solve for b?
How would you, would it just, what's the, general equation for, y-intercepts?
When you have the equation of a line, it means that every single point on that line has to fit that equation. Okay? Yeah. Let's say I have this equation. That equation is y equal x plus 3.
Okay.
Okay? In other words, it goes through the y-intercept at 3, has a slope of 1, so that's the equation of that line. Okay? Okay. Well, if I came down here and said, is there a point down here that's on that line, is minus 4 comma 2 on, or minus 4 comma minus 2 on that line, well, how would you tell? It has to fit that. In other words, I have to be able to plug in the y and the x value and have it be an equation. And you can tell that this point would not be on that line.
No.
Right? Because if I plug in minus 2 for y and minus 4 for x and do the math, I get minus 2 equals minus 1.
Which isn't right, yeah.
Right. So when I say is a point on a line, it has to fit the equation that we eventually come up with. Okay? Yeah. Meaning I have to be able to plug in x and y. So my problem here is to solve for b.
Yeah. So you'd plug in.
Here's an x, there's a y, and we know that we know that point and we know that point are going to fit the equation of the line. They have to by definition.
Yeah.
Okay. So let's plug in the x and y value from one of these points, and either one is good, into that, and that will let us solve for b. Notice we'll only have one variable if I plug the x and the y values in. So which point should we pick?
We could do 2, 1, plug in.
Always the one with the smallest, easiest numbers, positive coefficients. There's at least two reasons to pick that point.
Yeah,
It's got both positive numbers and it's got no negative coefficients.
Okay.
So what can I write now in order to solve for B?
1 is equal to -4 fifths times 2 plus 1.
Plus B.
Or plus B, okay.
I don't know what B is. But it's not 1.
No.
I mean, it doesn't figure to be 1. It would be accidental if it was 1. This whole reason I'm doing this is to solve for B. Okay, so now I've got 1 equals minus 8 fifths plus B. How do I solve that for B?
And then we would subtract -8 fifths from both sides, or add -8 fifths from both sides.
Add 8 fifths.
Yeah.
That's the same as what you said. You said subtract a negative. Well, that's okay. But that's the same as adding 8 fifths. So what's B equal
to? So B would be equal to 8 fifths, wouldn't it?
No, it's 1 plus 8 fifths. How do I do that math?
You find a common denominator.
Okay. Do it in your head.
Okay, so common denominator would be...
Fifths is 1. How many fifths is 1?
5.
Okay. So it's 5 fifths plus 8 fifths. That's why I say you can do these in your head most of the time, especially when the number is 1.
So it would be 13 fifths.
Okay, what's my equation of this line?
So it's going to be y is equal to -4 fifths x plus 13 fifths.
There you go. Okay. If you can do that problem and do it every single time, then you're halfway home. Okay?
Cool.
Because they're going to either give you 2 points or 1 point and 1 slope. And we just showed that even with 1 point only, once I had the slope, then that's all I need to solve for B, is 1 point and a slope. So let me give you another problem.
Okay.
I have a slope of 2, and it goes through the point 3, 4. What's the equation of the line? Starting always, this is a good way to start, write the general.
Okay. So it would be 4 is equal to 2x plus b.
If I write 2x plus b, I cannot solve for anything.
No, 2 times 3, my bad.
Okay.
Yeah.
What's b equal to?
So it'd be, okay. So you subtract 6 from both sides. Okay. So it'd be -2.
Okay. What's the equation that I seek?
Y is equal to 6x, or 2x minus 2.
And that's the answer.
Okay,
cool. So, you know how to do point slope? That's what that is. And you know how to do 2 points.
Cool.
Okay, now, what is the slope of a line perpendicular to this line? What I have here is the equation of a line. Okay, in other words, I could graph it. I would start at -2. I would go up 2 to the right 1. There's the graph of that equation.
Okay. And it's always the opposite reciprocal.
What's the slope of a line perpendicular to that? So what is it? In other words, this slope here has a slope of 2. What's the slope right there equal to?
1/2. -1/2. Because
always remember
slope
you got to do
2
things.
Okay.
Not just one thing. saying it was 1/2 was just doing one thing. You were just taking the reciprocal of it.
Okay.
You got to do two things, -1.
Mm-hmm.
And
okay.
you can look at it and see that that's a negative slope. So
yeah.
if you're ever in doubt, just approximate the slope and then draw a perpendicular and realize, the slope's always the other sign. No matter what my slope is, it's always the opposite sign for the perpendicular. So, 4-3. Give me the equation of a line that is parallel. Here's the line we came up with. Okay?
Okay.
That was the equation of the line. Now give me the equation of a line that is parallel to this line and goes through this point. In other words, I don't know that this line goes through this point. I don't think it does. 3 does not equal to 8 minus 2. So this equation does not go through that point. But if I said, give me the equation of a line that's parallel to this line and goes through this point, do it.
Okay, so let's see here. How do we find...
Start with the slope. What's the slope of our new line going to be equal to?
2.
Okay. Now we got slope, point. Forget the original. Just operate here. You have enough information now to come up with the equation of this line. I have a slope of 2, and I'm going through this point.
Okay. So it would be y is equal to 2 times 4.
Okay.
Or just 2x.
Let's start there.
Okay.
Now what? Because that's a key step, is to start there.
Yeah.
You were trying to do
now
at 1.
Yeah. Now it would be 3 is equal to 2 times 4 plus b.
What's b equal to?
B would be equal to -5.
And what's the equation of this line?
Y is equal to 2x minus 5. And then that's, okay. That makes sense.
You got it?
Yeah,
okay,
that makes sense.
Now, let's go back another step.
Okay.
Give me the equation of a line that is perpendicular to this line and goes through the point 3, 5.
Okay, so for this one it would be y is equal to -1/2 x plus b to start out. And then the next one would be 5 is equal to -1/2 times 3 plus b. And then that would be 5 is equal to
trying to solve for b.
Yeah, so it'd be -3 over 2. 5 is equal to -3 over 2, yeah. Plus b. And then you would add 3 over 2 to both sides.
Okay.
And then you would get, let's see here.
Leave it as a proper fraction.
Oh, okay. So let me see. 2.
So I've got 5 plus 3/2. Right? That's what b is equal to? What is that equal to?
16 over 2, which would be...
How many halves is 5?
2, 5, 5, yeah.
10.
Oh, 10.
Remember how I do it. It's 5 over 1. So I divide 1 into 2, I get 2. I multiply 2 times 5, I get 10.
Okay.
So I'm multiplying top and bottom by 2 to get 10 halves.
Okay.
And then I look at it and I make sure, is 10 halves the same as 5? Yes, it is.
Yeah.
So I've done it properly. Okay.
Okay.
10 halves plus 3 halves?
Would be 13 halves. And then that's your answer.
That's your answer. So the equation is what?
Y is equal to, what was the slope? 2x? Oh, yeah, negative 1/2 x plus 13 halves.
There you go.
Okay.
And that's the equation of the line that was perpendicular.
Okay.
So at this point, you should be able to come up with an equation of a line given 2 points, given a point and a slope, or given the slope is parallel or perpendicular to another line.
Okay.
Okay, but you always need at least 2 points of information, and slope is always one of them. It's just when they start out a problem by giving you 2 points, obviously the very first thing you want to do is calculate slope. That's the most important thing. Always remember, slope is the most important thing. It's going to be in geometry and trig and calculus and pre-calculus. It's just that important. So remember slope.
Okay.
All right. Let me go on here a little bit, see if I can.
Okay.
And your homework this week will be on this material here, slopes and equations of lines and stuff.
Okay.
So I think it'll actually be good for you to practice a little bit. Just a second.
Okay.
Trying to figure out. Standard format. First of all, let's talk about the formats.
Okay.
There's slope intercept.
Point.
That's y equal mx plus b, and it's called slope intercept because we need a slope, we need an intercept.
Yeah, exactly.
If you have it in this format, it's pretty easy to graph.
Yeah.
Okay.
For sure. Okay. Then there's standard format.
Right. Let's talk about standard format. Standard format is when you have all the x's and the y's on the same side, and you have ax plus by equals c. An example of standard format would be if I had 2x plus 3y equal 12.
Yeah, which is what we were doing last night, or yesterday.
Yeah, now, if I said graph that, what would you do?
Well, first you have to get it into y equals mx plus b format.
Well, it turns out there's significantly easier way to graph it when it's in standard form.
Okay.
And it's worth telling you about. You could do it the other way. In other words, you could get it. Let's go ahead and have you do that just for practice, as long as we're talking about it.
Yeah, so you would subtract 2x from both sides.
Okay, so now I have 3y equal 12 minus 2x.
And then we would divide by 3y.
Not by 3y.
Or divide.
Divide by 3.
Divide. Yeah, divide by 3y from both sides.
No. If I divide by 3y, this is what I'm saying to do.
Yeah, my bad. Just
That's
3.
That's going to leave 1 on the left side of the equation.
Yeah.
Okay? So
Okay.
you're always dividing by the coefficient, not the coefficient and the variable, but the coefficient. So now that leaves y, because those become 1. And over here I have 4 minus 2/3 x, which I can write as minus 2/3 x plus 4. Now I have it in format that I can graph easily.
Okay.
Okay? But that was a lot of work.
Yeah.
Okay? There's an easier way to graph it when it's in standard format, especially when it's in standard format and looks like this.
Okay.
And that is to graph its x-intercepts and its y-intercepts.
Okay.
What's the definition of y-intercept? What is x going to be when I have a y-intercept?
X would always be 0.
Right.
Yeah.
So let's solve this for y, letting x be 0. What do you get for y?
So you're just, if x is 0,
Solve it for y.
so it'd be just 3, y is equal to 12, then you just get y is equal to 4.
There's the y-intercept by definition.
Okay.
What's the x-intercept?
The x-intercept would be 6.
Because the x-intercept means y is 0.
Yeah, exactly.
So I can draw that at 6, I can draw that at 4, and it's just a straight line between the 2 points.
Yeah.
What was easier in terms of graphing it? Was it this way or solving for y and then using y equal mx plus b?
That way was much easier.
This way was a ton.
Yeah, for sure.
Especially as long as these are easily divisible. Now,
yeah.
Make that 13, not quite as easy. You still can do it. In other words, the x-intercept instead of 6 now is 13 halves.
Yeah.
Maybe right there. And the y-intercept, instead of a nice round number, is 13 thirds, maybe right there.
Yeah.
So just introduces fractions, but still it's an easier way to do it than the other way, because doing it the other way isn't going to be so easy here either.
No.
In other words, you're going to have lots of fractions that aren't going to be easy to deal with. So remember when it's in standard format that the easiest way to graph it is to just graph the x and y intercepts and connect the 2 dots. Notice that when you do it that way, you don't have to pay attention to slope. At no point did I need slope. Because all I needed was the y-intercept was at 4, the x-intercept was at 6, and I connected those. I don't even know slope. I don't care.
No.
It's all, if the question said merely graph it, then I've graphed it.
Yeah, exactly.
All right.
Okay, cool.
Yeah, it'll take me a half an hour or so to send your homework to you, because I want to make sure that what I'm sending you are problems that we covered today.
Yeah, exactly.
And I didn't really know them in advance.
That's all right.
So
yeah.
There is one other format that's called point-slope format.
Yeah.
I don't know that you need that, to be honest.
I don't think we've ever gone over it, yeah.
It makes things simpler sometimes, but you don't ever have to use it. Not at the level of math, you won't have to use it. They may want you to know it. In other words, you may get somebody asking you a question, do this in point-slope format, well, then you're going to be out of luck. But for the moment, I want to stick with just standard format and slope-intercept, because you can answer all of these questions using those.
Yeah, for sure.
All right.
Okay.
Good place to stop. We've covered that subject pretty good, and I've got some good homework for you. How long did it take you to do those others?
Okay.
Homework-wise, how long did it take you? I don't want to assign you too much. How long did it take you to do those problems I gave you last time?
About 35, 40 minutes.
Okay, good. Just so I have an idea. I don't want to overlook that. That's probably about right then. Okay.
Okay.
Neil and I will talk to you, I believe, on Wednesday at 11.
All right. Sounds good.
Okay, bye-bye.
All right. Thanks. Bye-bye.